So this is going to be a video about limits and continuity, and using the definition of continuity with limits, we are going to be solving 3 example problems here. So we're going to start with a really quick review of what the definition of continuity is. It's basically what's highlighted in yellow right here. I'll just circle it in red. All 3 of these things have to be true at point x equals c in order to be continuous at that point c. So that's basically the definition of continuity using limits, and we're going to use this definition to solve 3 example problems. So here we go. All right, so this first example, it says, is f continuous at -1? Okay, so we're going to have to use our definition here, so I'm going to put that in the shot here. All right, so first thing I'm going to do is I'm going to find that f of c. In this case, it would be f of -1, so I'm going to write f of -1. Now I'm doing this f of -1 just because it's the easiest thing to find rather than the limits. Just involves the least amount of thinking. So to find f of -1, you have to figure out which piece are you going to use, this top piece here or this bottom piece. Well, it says f of -1. That means x is equal to -1, so you're going to have to use this piece based on this right here because it says x is less than or equal to -1. So we need to use this because technically x is equal to -1 for this piece. So you would have 2 divided by -1 squared, which is going to be 2 divided by 1, which is equal to 2. All right, so we figured out this first part here. Next, we're going to do the limit from the right. So I'm going to write that down here. The limit as x approaches -1 of f of x. All right, so for this limit, you have to have the little plus here because we're going to be looking for this first one. It's got a little plus there. So what we're going to do is we need to figure out which piece, it's either the top one or the bottom one here, and that involves -1 from the right side. And that means it would be greater than -1. Well, this bottom piece here has the x is greater than -1 right here, so we're going to have to use that piece right there. And I'm going to do direct substitution first, so I'm going to plug in -1 for x on this bottom piece here. And you get something like this. And what's great about this is it actually solves out. So you end up with 2 on top divided by cosine of 0, which is 1. So you get 2 as well. So far, this first part right here works, and this part right here. So now the last thing is we got to test that middle part. So we have to test this part right here. Okay, I'm going to do that a little bit below here. So we're going to do the limit as x approaches -1, this time from the left, of f of x. Okay, now obviously we're going to have to use this top piece since we used the bottom piece on the last one. This one's where it's x is less than or equal to -1. Well, we want x from the left, so this would be the piece we're going to use. Now we already solved this part right here, so it's actually going to share the same value as this first piece here. So if you notice, all of them are equal to 2. So based on our limit definition up here, you would say yes, in fact, this is continuous at -1. So that's basically the answer for the first example. All right, let's do example 2. Okay, example 2, it says, is h continuous at x equals 1? So first thing I'm going to do, again, I'm going to find f of 1. Okay, now I'm going to need to figure out which piece do I use, the top piece or the bottom piece. Well, this one says x is greater than or equal to 1, so we're going to use that piece. So I'm going to plug in 1 for that, and you end up with just the square root of 2. Next, I'm going to find the limit as x approaches 1 from the right. I just realized this should say h of x. So we're going to put an h in here. There we go. Just trying to be accurate. Okay, this one, the limit as x approaches 1 from the right of h of x. Now we have to figure out which piece are we going to use. Well, it's the one that's bigger than 1 because it's from the right, so it's a slightly bigger than 1. So we're going to have to use this piece right here for that, which we already did. So we know that it's the square root of 2. It's going to share the same value as the one before it. And last but not least, we're going to do the limit as x approaches 1 from the left. So the other one was from the right. This one's going to be from the left. Okay, now we're going to have to use this top piece here because since it's from the left, it's less than 1, so we need to use the one that's less than 1. All right, we're going to plug in 1 to that top piece, and you're going to get -1 plus 1 and the square root of all that. So that ends up breaking down to 0. All right, so now we have an issue. If you notice, all 3 values are not equal. So because of that, you would say no, h of x is not continuous at 1. So that answers that question right here. So the answer would be no. And the proof for it is right there. All right, now this third example is pretty much the hardest example, so I kind of kept it for last for that reason. Here it's a bit of a curveball because it says what value of k makes g continuous. So if you notice right here, there's a k constant that we're trying to figure out. So what is that value of that constant that makes this continuous? Well, luckily we still use the exact same definition of continuity to solve this one. So first thing I'm going to do is find g of, in this case we're going to do -3. If you notice, it's kind of like the boundary for both of these pieces is -3, and that's generally what you're going to want to do is look at what that boundary is because it has to be continuous at this point. If you notice, if you plug -3 in to this first piece here, you're going to end up with a 0/0, which means there's a hole there. So essentially what this k is doing is filling in that hole. So we need to figure out where is that hole, and then k has to be that value so that hole is filled in. So that's what we're going to do. First thing we got to do is find g of -3. So I'm going to do that really quick. Now, this is where x is equal to -3, so you might be thinking, which piece do we want to use? We actually want to use the second piece because it says x is equal to -3, and that's what we have right here. G of -3, x is equal to -3. Well, that's going to be equal to k, okay, just based on the definition of g of x. Next thing we're going to do is we are going to find the limit from the right side as x approaches -3 of g of x. Okay, now you might be thinking, which piece do we use? Well, we can't use this piece because this is just basically an island. It doesn't have a side, it's just one point. This other piece is the piece that we're going to use. But a thing you should notice is it's not less than or equal to, it's just not equal to. That means it's approaching it from both sides. So if we want, we can make this simpler by noting that the limit has to agree on both sides for this because there is no less than or greater than. So we can, I'm just going to set them both equal to each other here because they are going to be equal because they're both using that same piece up top. All right, so this is going to be equal to the limit as x approaches -3. That's just their definition. They have to, if the one-sided limits are equal, then that double-sided limit is going to be equal. So I'm just going to write that down. And instead of g of x here, I'm actually going to replace it with the function. So x, or the expression I should say, 6 over x plus 3. Okay, now, so this is just a standard limit problem that we're solving. First step is direct substitution, so plug the -3 in. We kind of talked about that before. You end up with a 0/0 if you do that. So that means something is going to cancel here. So that's what I'm going to do next, is figure out what that is. So first thing I'm going to do is factor the top. So I'm just going to get rid of all this and factor it. We know -3 causes the 0, so that means that x plus 3 has to be a factor here. And if you notice now, this and this cancel. Okay, now you're left with x plus 2. So that means you can do direct substitution. You can just plug the -3 in. -3 plus 2 is equal to -1. Now, based on our limit definition of continuity, all three of those things have to be equal. So what we need to do now is basically set this equal to this, which is actually what we're finding. It says what value of k makes g continuous. So it would just be k is equal to -1, and that's the answer. So if you have any questions about anything in this video involving limits and continuity, let me know.